Good day again, guys. Today we will be doing a reaction between potassium iodide and hydrogen peroxide. Now, this reaction you would have seen, you might have seen in other places where it is very vigorous, and the product that is produced is commonly called elephant's toothpaste. Now, the reaction that we are going to perform is not going to be that vigorous because we are not going to be using concentrated reagents to do this reaction that we will attempt to do in this chemistry experiment. We'll be using diluted reagents to perform this reaction. This form of reaction is a type of redox reaction. As I said before, we'll be using potassium iodide and hydrogen peroxide, and we'll also be using a small portion of dilute sulfuric acid because, as you should know by now, this might be new knowledge but not a problem. Redox reaction occur much more effectively in an acidic environment. So we'll be using dilute sulfuric acid to create that acidic environment for the reaction to be as effective as possible. So that is basically what we'll be doing for this experiment. So we will begin. The first thing that we're going to do, we are going to add the potassium iodide solution. But I want you to look at the color of the potassium iodide solution before I add it to the test tube. Right? It's not colorless. It's not colorless, but it is not an intense color. It has a shade, but it is not colorless. So we're going to add it. So just notice the color for now, so that as the reaction occurs, you can observe any change that you will see. So we're going to add the potassium iodide. We're going to add the potassium iodide now in the test tube. Right? So we're adding the potassium iodide in the test tube. Right? So you can see the color in the test tube. As I said before, it's not colorless. It has a shade, but it's closer to colorless more than even the shade. Alright? So this is our potassium iodide in our test tube. What we are going to add now to our potassium iodide, we're going to acidify our potassium iodide by adding about 3 drops of dilute sulfuric acid. Alright? So we add about 3 drops of dilute sulfuric acid. Right? 1, 2, 3. Right? So our sulfuric acid was added, and we shake it a little. So we observe also we're not getting any change in the medium when it is acidified. It is acidified, the potassium iodide is acidified, and we're not getting any change. However, so now we are going to add our hydrogen peroxide. Right? So this is our hydrogen peroxide, and we're going to add our hydrogen peroxide. You can also notice the color of the hydrogen peroxide. Notice the color. We're getting a clear color, a colorless color for now for our hydrogen peroxide. Alright? So observe the initial color of the reagents, and we are going to add the hydrogen peroxide now into our acidified medium of potassium iodide. Alright? Notice the color again. As I said before, it has a shade, so it is not colorless. It has a shade that is, could say this is what we could say a pale yellow, whichever color it is, but it is not colorless. Alright, so just notice that color. And so we now add our hydrogen peroxide to our acidified medium of potassium iodide and observe for any changes. Alright? So we add gently. Remember, we're doing chemistry. Alright? Alright, so we observe as we add. So we can actually see changes already. Right, so we actually see changes already. Alright, so we're going to observe that. We're going to shake it gently. And we know the way that we shake gently and we observe. Right, so we can actually see changes already. So we're going to observe that for a short while. So we're seeing a color change. We're seeing a color change when the reaction took place between acidified potassium iodide and hydrogen peroxide. Now, as I said before, this reaction is not as vigorous as some of the reaction that you might have seen on the internet or in other places, because we are using diluted reagents. We're not using concentrated reagents. This is what we will do in a school setting, right? So we will not expose the students to concentrated reagents to perform this experiment. All right, so this is the end result of a reaction between potassium iodide, acidified potassium iodide, and hydrogen peroxide. All right, and remember, these are diluted forms of the reagent. So the hydrogen peroxide was diluted. The concentration was 6%, and the potassium iodide was also in a diluted form. All right, so they were not concentrated reagents. However, you can still see that a reaction took place, right? And we're getting a new color change compared to what we are getting a color change compared to what we compared to the colors that we had before of the hydrogen peroxide and the potassium iodide. All right, so we could say this color, you can describe this color. You can always use your literature review to describe this color, but I would say that this is my opinion. I could say this is a dirty orange brown, reddish brown. I could say this is a reddish brown. I could say this is a reddish brown. Right, so I could say this is a reddish brown. A reddish brown mixture was formed. At the end of the reaction between potassium iodide and hydrogen peroxide. But you guys can do your literature review, and if you want to put another color that you are seeing, once it is in line chemically, I don't see where we should have a problem. So just consult the color. You can always do your literature review to consult the color. But let me get on white background, and so you guys can see the color that I'm seeing here. I'm seeing reddish brown or orange brown, one of those colors. All right, you can always do your literature review to confirm that. But this is the end result of what we are seeing. I'm just look to see if we are seeing any effervescence, bubbles. Saw a little bit of bubbles, a little bit of effervescence was seen at the start of the reaction. Right? So, however, we are going to now test to see if we can identify at least one product of this reaction. Right, we're going to test and see if we can identify identify at least one product of this reaction. Right, so I'm seeing effervescence, I'm seeing bubbles, and that bubbles would imply that a reaction took place. As we can see, a reaction took place, and the effervescence, let me give a close up to see if you guys can see. The bubbles are they are not enormous, so you probably will not be able to see them through the phone, but I am seeing some bubbles, and that bubbles will be coming from the decomposition of the hydrogen peroxide, which is liberating oxygen gas. Right? It is the hydrogen peroxide, when it is decomposed by the potassium iodide, it would liberate oxygen gas in the process. Alright? So the hydrogen peroxide is in this reaction, the potassium iodide is decomposing the hydrogen peroxide, and that is causing an end product of this reaction to be oxygen gas, which is seen in the form of bubbles or effervescence. Alright, so we are then now going to test for one of the products of this reaction. We're going to test if iodine was formed in this reaction, and to do that we are going to add some of the contents of our test tube, to starch suspension and see what is formed. Alright, we're going to use a white background to do that. So this is our starch suspension. And we're going to add some of the contents of our test tube to our starch solution and see what is the result. Let me show you guys the color of our starch suspension. Right, it is cloudy. So we're going to add a portion of our mixture from our test tube to our starch suspension and see what is the end result. Alright, so we add. Alright, we're testing for iodine. By the way, we are seeing some precipitate. Also, we are seeing some precipitate in our test tube. Small amount. So we add. Alright, so we add, and we are seeing we got a color change. Right? So whenever iodine comes in contact, is reacted with starch suspension, you should get theoretically a blue-black color change, and that is what we are seeing here. Right? If we can look, we're seeing a blue-black color change. So that means, as we're just confirming that the reaction took place, but we already knew based on the result that we got that the reaction took place, but we are just confirmed by doing a confirmation test. And the confirmation test that we did was to react the mixture that was found in our test tube with starch suspension, and we are getting a blue-black color change. So we are now certain that iodine was formed in this reaction. Alright? And we are also certain that oxygen was liberated because we saw the bubbles or the effervescence that were given off in the test tube. Alright, so this reaction was successful. Remember that this was a reaction between potassium iodide and hydrogen peroxide in an acidic environment. Alright, so remember, this is the end product, this is the end result of our reaction. Alright, this is the end result of our reaction. Alright, and our reaction was successful today. So hopefully you guys would have learned something again today about redox reaction. Alright, always remember, in redox reaction there is one reagent that is the reducing agent, and one is the oxidizing agent. Alright, so there was an oxidizing agent in this reaction, and there was also a reducing agent in this reaction. I'm not going to tell you guys which which reagent was the oxidizing agent and which one was the reducing agent. But based on when you guys write your chemical equations, the oxidation reaction and the reduction reaction, you will be able to see which reagent was the oxidizing agent and which one was the reducing agent. Thank you very much. Hopefully you guys learned and we all learned something today again.